In practice problem 2, we want to calculate the number of seconds in 2 years. And what we want to start off is with our GWR. You don't always have to start with GWR. You can if you'd like to. I'm not going to count off if you don't, but it is a great way to help organize your thoughts. So the given in this problem is 2 years. We want to know about seconds, and when it comes to our ratios, you're just trying to think of everything you know about relating years to seconds. Now in this class, we want to make sure to use the ratio that in 1 year there are 365.25 days. This accounts for how every 4 years there's an additional day, which we call a leap year. And so if you split that up between 4 years, just to get an average, each year averages 365.25 days. So that's the conversion we're going to use in this class. I know that in 1 year that's equal to this many days. I'm trying to get to seconds, so I know also that in 1 day there are 24 hours. I also know that in 1 hour there are 60 minutes, and that in 1 minute there are 60 seconds. So just to make sure my pathway from years to seconds is complete, I go from years to days, days to hours, hours to minutes, minutes to seconds. So I know that the pathway is complete. Can start the problem with a given over 1. I want years to cancel with years, so this piece of the ratio is going to go in the denominator, and the other side of the ratio goes in the numerator. So remember, with dimensional analysis, with a ratio, everything that's a ratio is going to go above and below each other, and the way we know what goes in the bottom is that we want the units to cancel out diagonally. We want them to be the same diagonally. So if I have days in the numerator here, I need days in the denominator here, which I'm going to pull from this ratio. 1 day is equal to 24 hours. 1 hour has 60 minutes. And finally, 1 minute is equal to 60 seconds. In my calculator, I can type 2 times 365.25 times 24 times 60 times 60, and that will give me a number that looks like this, but rounded to one significant figure because the given is one significant figure. I went ahead and converted this into scientific notation. Remember your calculator, not your calculator, I'm sorry. With scientific notation, your decimal place is here, and you need there to be just one significant figure in front of the decimal. So to figure out this exponent, you move the decimal over 1, 2, 3, 4, 5, 6, 7, and that's where my exponent of 7 comes from. To properly determine the units, anything that doesn't cancel out is part of your answer.